Okay, students, today we're going to talk about graphing rational functions. They're called them reciprocal functions here. So I would say rational, because again, anything that's written as a fraction is a rational function or expression. These are all written as fractions. Okay, so the parent function, remember parent function means before any shifts occur. There's no horizontal or vertical shifts, no horizontal or vertical stretches either. Okay, so the original is called the parent function, y equals 1 over x. Now it's interesting, they're calling parent functions, but it's going to write in function, you should write in function notation, which then would be f of x equals 1 over x. So you need to know those are the same thing. Okay, and you notice down here in their examples, they go ahead and do it correctly and write it as f of x in all their problems. Okay, so they should have put that up here, okay, as well. Type of graph is called a hyperbola. That's what it graphs into, is a hyperbola. Hyperbola is when you have two branches. These are each called a branch, okay, which are curves. Those are branches. All hyperbolas have two branches. Most of the time, they're in opposite quadrants. So this would be like quadrant 1, because remember, if you think of this now as this asymptote, and this is the other one, this would be quadrant 1, and this would be quadrant 3, right? You should already know your quadrants, 1, 2, 3, write them in Roman numerals, of course, and 4. So opposite quadrants, 1 and 3, that's almost all the time. You can have exceptions when you have absolute value. When you see absolute value, then they'll both be in the same quadrant next to each other. It's like 1 and 2 or 3 and 4. They'll either be in the top 2 or the bottom 2 if they're dealing with absolute value. I don't know if they deal with any, no absolute values here. So therefore, these will all be in opposite quadrants. Okay. Domain, all non-zero. That means at 0, it's undefined. Remember, you can't have 0 in the denominator. I can plug any other number in I want besides 0. So that's why it says all non-zero. Okay. The range, remember, so the domain, remember, the x coordinates or x values that you can plug in. Range, you should already know, is your y values that are graphed. Okay. The range will be all non-zero real numbers. So again, you're not going to get a 0 on the y either on any of these unless there was a shift. But again, we're talking about the parent function up here. So we have an asymptote at the x-axis. Remember that equation is y equals 0. You should know that from Algebra 1 in geometry. Okay. The equation of the y-axis is x equals 0. Again, you should know that from Algebra 1 in geometry. Okay. So it will never touch the x-axis or the line y equals 0. So asymptotes will get really close to it. It will not touch it. Okay. Symmetry means is there a line that reflects one branch onto the other over the x and the y axis. Okay. I'm hoping they mean by that like a rotation of one over both. You have to do both over the x first and the y, or y then the x. That'll put it in the opposite quadrants. So I'm assuming that's what they're talking about. Okay. All right. Intercepts. Is meaning the x-intercept or the y-intercept, meaning we're across the x-axis or the y-axis. So if we look back up here, so they don't have the graph of this, so the graph of this looks like this. That's the first quadrant one. Here's the second quadrant one. Okay. So, symmetry, I would say y equals x. Most famous line in math, you know that from Algebra 1 in geometry. Okay, it reflects right back onto itself. Okay. Intercepts, none. I mean, does it cross the x-axis or the y-axis? No, it does not. Those are both asymptotes. And here you see the word asymptote right there, the x and the y-axis. So they're always, when you do your asymptotes, you always put them dashed like this. Okay, even if it's x or y, so dash them. That's why you saw my line y equals x right here, dash, because it's not really in the problem. That means it's not in the problem. It's not part of the actual graph. Okay, the graph itself are these two branches. That's the graph itself. Okay, the two branches. So asymptotes, again, as I told you, are lines where the curve or the branch will get really close to but never cross. Okay, you'll come across some later that will, but then if they do cross, they have to come right back down near that asymptote again. But the vast majority you come across in Algebra 2 will not cross at all. So the y equals 0, the x-axis is called the horizontal asymptote because that's a horizontal line. In the y-axis, equation x equals 0 is called the vertical asymptote because it's a vertical line. Okay, so know that. If I ask what's the vertical asymptote, you tell me x equals 0. If I tell you what's the horizontal, ask what's the horizontal asymptote, you tell me y equals 0. Okay, so the asymptotes, even though they wrote them as the x and y axis here, they usually will never have them like that in the answer key. It'll be y equals 0, x equals 0. You have to write the equation of the asymptote. Okay, so don't think you can get away with the x and y axis here. This one might, but that's not normal. Okay, you need to write the equations of those. All right, so let's go ahead and look here now. You can pause the video, writing that down you haven't written down, and then come on here. All right, so here we go. Identify the asymptotes. Notice that's plural. That means the horizontal and the vertical. The domain, or that's all the x values that can be graphed, and the range, all the y values that can graph of the function. Notice it does not say to graph it because they've already got graphed here for you. So apparently, let me see on the next page if they're going to talk about how to graph them. Yes, okay, so the back side they're going to talk about the rules for graphing. So I won't go ahead and talk about them here. I'll wait till I get to the back side. So right now we're just looking at the graph. This is the graph. If you were to plug this in the graphing calculator, 3 over x plus 2. By the way, when you plug it in the graphing calculator, since it's got more than one term in the numerator and the denominator, you must put parentheses around the denominator in this case. So let's just quickly look at that here so you can see. 3 divided by x plus 2 and 3 divided by parentheses x plus 2. If you think they're the same, then I would have one, when I hit graph, I will only see one set of one pair of branches, the same ones. Okay? If you think putting them in the same way, either way is equivalent. If these two are different, it means 3 over the number 1, y sub 1 is different from y sub 2, you're going to see 4 branches, 2 pairs of each, because they're different. So let's see. There you go. You see 4 total, 2 pairs of each, meaning that they are not the same. Okay. The one we're talking about is the second one. I told you when there's more than one term in either the numerator or denominator, you've learned this, you should learn this in Algebra 1. I pounded it in Algebra 2, in geometry, and now you're seeing it again in Algebra 2 here. Okay, when there's more than one term in the numerator or denominator, you must have parentheses around it. So this one, I can go right there, clear. Let's clear that right there. Okay, so this is the one we were looking at. That's the one you see on your paper. Okay, right here. So we are identifying the asymptotes. Well, the one asymptote right here, what's the equation of the x-axis? Y equals 0. What's the equation of this line right here? x equals -2. Okay, now where do you get that from? You just set the denominator equal to 0 and solve. X equals -2. When you set the denominator equal to 0 and solve, that's the vertical asymptote. Okay, assuming that you couldn't cancel with anything in the numerator at all, which you can't here. Okay, you always do cancelings first. And we'll be talking about that on the next page. Okay, so there's vertical asymptote, horizontal asymptote, y equals 0. So we took care of both the asymptotes, plural. It means you better have 2. Domain, all the x values. Remember, I cannot have what number in the denominator? 0. So the domain is all real except for x equals -2. If I plug in -2 in for x, I get 0 in the denominator. So domain is all real except -2. The domain is all real numbers not equal to -2 right there. The range, remember the range, here we have a horizontal asymptote. It's going to graph every y value besides y equals 0. So that's why it says the range is all real numbers not equal to 0. And there you go for your answer. Okay. And that covers the first page. All you're doing is doing those same steps on those 3 right there. Now the back side. Transformations, remember that's when you shift them. We've done shifts. We've done shifts in Algebra 1, in Geometry, now you're doing it again in Algebra 2. We've already done it earlier in Algebra 2 with parabolas. Okay, you've done it with absolute value graphs. Remember those were V's. You did your shifts, you've done with parabolas, you've done with square root functions, you've done with log functions. Okay, now we're doing with algebraic expressions. Okay, so the vertical asymptote, again, is when I set the denominator equal to 0. So I do that, I would get x equals h. But I add the h across. Okay. The horizontal asymptote is the k itself. Okay, whatever k happens to be, that's the horizontal shift up or down, whatever k is. Remember the vertical, the x minus h equaling 0, that's the vertical shift. I mean the horizontal shift, left or right. Okay, and then the equation is x equals whatever h is. Okay, so that's the vertical asymptote, horizontal asymptote. Reflection. If there's a reflection, it's when a is negative. That reflects it over the x-axis. Okay, it flips it up over the x, or reflects it over the x-axis if a is negative. Okay, compression and expansion. Those are the same as the vertical stretch or horizontal stretch. In other books, they call them that. Compression would be compressing in. And so, oh no, they want compression vertically. Okay, so that's the compression would be your vertical stretch. Okay, and that's when A is shrunken vertically. Okay, and that's when A is absolute value of A is less than 1. Okay, which is between 1 and -1. And expanded vertically when A is greater than 1. Absolute value of A is greater than 1. So 1.1 on up and -1.1 on down. Okay. And so let's talk about that number right there. If it's not 1. Okay. All right, here. Graph that. State the domain and range. So we want to talk about what all of our pieces are first to help graph. Instead of just plugging the graphing calculator, your goal would be you have to be able to do it by hand without a graphing calculator on this, just so you know. So there's nothing to cancel in the numerator and denominator. So vertical asymptote, set that equal to 0, x equals -1. So I should have a dashed line right there, x equals -1, and you write the equation right above it, so I know you know what you're talking about. I have a horizontal asymptote. So HA for horizontal asymptote, VA for vertical asymptote at y equals -3. So I go down to -3 and do a horizontal asymptote. Draw that in there with dashed lines. Okay. Now I have -1/2. Okay. The negative told me that, remember, the normal one is in quadrants 1 and 3. So since it's negative, it's going to reflect this down to this one. It's going to reflect this one up to there. So now I'm going to be in quadrants 2 and 4. Okay, with that negative sign. That's the negatives. It has nothing to do with the 1/2. It's the negative that makes it reflect over the x-axis. Okay, so that's why you see it in quadrants 2 and 4. Okay, think of your new vertical and horizontal asymptote as your new origin. So this is now the new origin. And so those are my quadrants. So that's why you see the two branches in quadrants 2 and 4 got reflected over the x-axis with that negative sign right there. So now what we have is I can make a t-chart if I wanted to. What to say? State domain and range. Okay. So the graph, instead of being the normal one of 1 over x, which looked like the one we had on the other side, that graph on the other side, it's now smaller a little bit. It's almost the same shape practically, you know, as far as the two branches. It's still got the curve like that, except for it's just shrunk in more. Okay, because 1/2 now. Okay, so if you were doing it by hand, we've taken care of the horizontal and the vertical, so it takes care of that. Okay, we've taken, and now I'd have f of x equals -1/2 over x. Okay, and I could just do an xy t-chart. So if I plug in, say 2, x equals 2. Let's go, let's make nice numbers. -1. -1/2 divided by -1 is +1/2. Sometimes if I go left 1 from here, this is my new order. I go left 1, I go up 1/2. Right there. Okay. If I go left, let's say if I go left 1/2. Okay. -1/2 divided by -1/2 is +1. So I went left 1/2, I'm up here at +1. Okay. And so all you need is a couple points like this, and I'm just looking for the general shape of it. So you're gonna have it like this and like this. Okay. It's gonna look the exact same. Okay. Over on the other branch in quadrant 4. Okay. So this is how you would do it by hand. Okay. So by taking out and already drawn in my asymptotes, I can now cross out this and just deal with this piece of it. This is what the shape of the graph is right there. That one right there. The +1 and the -3 just dealt with the horizontal and vertical shifts. Okay, now I've already dealt with that. Now my new origin is right here. Okay, my new origin is right there. So I say 0, 0, that's 0, 0 right there now. And so I plug in the -1, I'm going -1 from that direction, from that origin right there, and -1/2 from that origin right there. Okay, and now that's easy to go ahead and plug in on your own and do, instead of having to use the entire equation, which most teachers will teach, to plug in something for the x and calculate the whole thing out. If you use the entire equation, then once I plug in that x value, that's the actual, then that's using this as the origin. Okay, if you use the entire equation, and you're going to want to do all that work, that's starting with that, regular origin itself. When you go ahead and take out these two right here, this now is your origin, where those two vertical and horizontal asymptotes intersect. That's your new origin. Much easier doing it that way. Okay, you don't have to. And of course, then you'd plug in the graphing calculator to check that you did it right. Okay, now, Algebra 2, it depends on your teacher on how tough they want to be. They could be easy and say, I'll just let you have the graphing calculator and play in the graphing calculator and do it on that way on the test. Well, for those of you going on to calculus, you have to be able to do this without a calculator. So for you people who are serious about math and want to go high math, you better learn how to do this by hand now because you're going to do it in calculus by hand on the AP test. Part of the AP test is non-calculator, part of it is calculator. And you will have a more complicated problem, but dealing with this kind of stuff and be able to graph it on by hand. Okay, so don't be lazy like the other kids could do if they want, if they're going on that high level and your teacher allows them to playing the graphing calculator. You learn how to do it by hand. Okay, so if you have to rewatch this multiple times to get it pounded in your head. So when you see it, you're going to do this again in pre-calculus and calculus. Okay, the faster you learn it now, it's going to be easy when you see it in pre-calculus and calculus. Okay. All right. I'm guessing possibly the next one we might get into more complicated ones. This is more basic right here, just so you know. We'll see about it. In my old Algebra 2 books, we got 2 more complicated stuff than these ones right here. We'll see on the next one.